So you're kind of getting an idea of what these are going to look like before we even graph them. The next one we're going to graph y equals absolute value of x and y equals, what was the next one? Absolute value of x plus 3. Do you see what's different about this one? Yeah. To have something to compare it to. A while ago it was outside the absolute value bars. Do you think this will do something different? I do. I do. Yes. Just because it's inside the absolute value bars, it will work a little bit different this time. The first one I'm not going to make the table for. Does everybody understand that we can very easily graph that? Looks like a V right at the origin. It's actually the lines y equals x and y equals negative x combined. We'll get to that later on, graphing those type of lines. Now let's graph this child function. X, y, I'm going to use the same numbers, negative 3, negative 2, negative 1, 0. I'm not going to use all of them. I'm just going to go up to 1. Do you see now what we're taking the absolute value of? Just the x? No, the x plus 3. So we're going to take the x out, put in negative 3. What is negative 3 and 3? The absolute value of 0 is 0. Do the same thing with your other numbers. Negative 2 plus 3 is 1. The absolute value is 1. Negative 1 plus 3. 2. The absolute value is 2. 0 plus 3. 1 plus 3. Now look, we got a problem here. Do we have our whole V shape? Negative 3, 0. 1, 2, 3. Negative 2, 1. And notice we don't. We don't have our whole V shape. So we got to plug in some different numbers to where we can get the rest of our V, because I don't know. What do you think? What's another number? What would you plug in next? Well, I did negative 3. Okay, so plug in, well, I plugged in positive 1. Any ideas? No, it's got a graph. I've just got to plug in some different numbers to where I get the whole V. Do you think it's going to come up and then go down to give us our V shape, or do you think it's going to come down and then come back up? You think come down here and then, so what number should we plug in over here? I plugged in negative 3 and got 0. Plugged in negative 2. Okay, we'll try negative 6. Plug that in. Negative 6 plus 3. Negative 3. Absolute value is positive 3. So negative 6, 1, 2, 3, 4, 5, 6. I got 1, 2, 3. Is that, you see what's going to happen? Let's plug in negative 4 and negative 5 as well. Negative 4 plus 3. Negative 1, absolute value is positive 1. Negative 5 plus 3 is negative 2. Absolute value is positive 2. So we get these two. So we have the whole thing now. So we can follow the pattern. Nope. It just slid it over again. Instead of sliding it up and down, it just slid it to the left that time. So if it moved from here to there. How far to the left did it slide it? 3. But that's kind of odd because it has a plus 3 in there. You would think that'd move it to the right, but actually a plus 3 inside there with the x moves it to the left 3. Any questions? So what would you think the absolute value of x plus 5 would do? Move it to the left 5. What about this? What would the absolute value of x minus 1 do? Moves it to the right 1. Good job. So inside, if we have numbers inside there, it's going to move it left and right. Something I actually skipped on that last one was also supposed to give the domain and range. My bad. We already have the domain and range of our first one. Let's go back and find the domain and range of the second one. What's the domain? What can x be? Is there anything that you cannot plug in for x? So domain, all reals. Domain. If you just want to put all numbers right now, I'll let you do that. Domain, all numbers. Range. Here's what we're trying to find the range of, is this second graph. Range is what your y's can be. Look at your y's. 1, 0, negative 1, negative 2, negative 1, 0, 1. I would look at my graph. I think it's easier to look at the graph to get your range. Your range is how far up and down your graph goes. Okay, it's your y values. Where does your y start down here? negative 2. Any questions? Does everybody see that your y's start at negative 2 and it continues up? Your graph goes up from there. So your y's, this is all you have to put, your y, your range, is greater than, is it equal to negative 2? Yeah, right there. Greater than or equal to negative 2. Any questions? Yes. Yeah. Well, from there to there. Okay, from here to where, which it doesn't stop. It continues. Now, if it started and stopped, let's address that. If it started here and actually stopped right here, then you'd have to say y is greater than. Let's go back and connect it with what we just did. Y would be greater than maybe. Go back to this. Y is greater than negative 2, but less than some other number. Does that make sense? So you'd have a compound inequality there. What about your domain and range here? We're just looking at the red one. Domain. Your graph goes to the right, your graph goes to the left. You can plug anything in that you want to, all real numbers. Your range. Where does the y value start at? Y's. 0. Your y values are your up and down values. This thing starts right here and it goes up from there. That is 0 because this is the y value of 0. This is 1, 2, 3, right? Negative 1, negative 2, negative 3. That starts at 0 and goes up. So for your range, you'd say y is greater than or equal to 0. That's your range. Questions? Let's do the last one. Huh? Not necessarily. Last one, y equals absolute value of x. I think we know how to graph that by now. And we're going to graph also y equals negative 3 times the absolute value of x. There's two different transformations happens to this. The first one, y equals absolute value of x. Let's graph that. You've got 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. There's the graph. That's the easy one. Now let's pick some values and graph this. Negative 3, negative 2, negative 1, 0, 1, 2, 3. If you do not get a V, then it is wrong. It's not a full graph. Let's plug in some things. I think we'll get the V with just these numbers this time. We're plugging it in for x. The first thing we're going to plug in is negative 3. But be careful. You've got a negative 3 outside this. What's the relationship? There's nothing. There's not a plus, minus. What's happening there? It's multiplication. Negative 3 times the absolute value of x. What's the absolute value of negative 3? It's 3. The absolute value of negative 3 is 3. So you have negative 3 times 3, which is negative 9. Plug in negative 2. The absolute value of negative 2 is 2. Negative 3 times 2 is negative 6. Plug in negative 1, you get 1. Negative 3 times 1 is negative 3. Plug in 0, you get... So stop there. 0, 0. Is this going to move left, right, up, down any? No, because 0, 0 is right where that was before. The next one, 1. The absolute value of 1 is 1. Negative 3 times 1 is negative 3. Do you see the pattern? It's going back up, right? Or actually going back down. Plug in 2, you get negative 6. Plug in 3, you get negative 9. Let's see what this does. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's negative 3, negative 9. Negative 2, negative 1, 2, 3, 4, 5, 6. Negative 1, negative 1, 2, 3, and 0, 0. 1, negative 3, 2, negative 6, 3, negative 9. Two different things happen.
It's upside down.
It is upside down, so let's talk about the upside down part first. That is a reflection. And I don't want you to just tell me reflection. I want you to give me what's called the axis of symmetry too. Tell me where is it reflected across. This is a reflection across, let's just say the y-axis. That is a reflection across y equals 0. You're right. Why is it what? Like, why is it skinnier? Let's talk about that. The negative flipped it. Okay, when it had a negative out front, that's what flipped it down, because think about it, if you take positive numbers up here, right, up here at the top, and you multiply a positive number by a negative, what happens? It flips it down to the negative side, right? So the negative flipped it. What did the 3 do? It made it skinny, pretty much. It stretched it. Okay, same thing if you take and you take that piece of silly putty and it's got somebody's face on it, okay, and you stretch that silly putty out, it makes it tall, long, slender, okay, tall and skinny. So that's what it did to your graph. What used to be at 1, it pulled down to 3. What used to be at 2, it pulled down to 6. What used to be at 3, pulled down to 9. Okay, it made it taller, made it more slender. So the negative flipped it over, the 3 stretched it out. See, any questions? That's a reflection across the y-axis, and I'm going to call it, since it stretched it up and down, that's vertical, right? We'll get into this more later on. That's a vertical stretch times what? 3. That's the two things that happen. It's a reflection across the y-axis and a vertical stretch times 3. Any questions?